All right. Hello, everyone. Thank you for coming for today's last talk. So after this, your suffering will be finished and you can enjoy some nice beers at the apero. But before that, we are going to learn a little bit about how to do automated Angular architecture validation with ESLint. So first of all, who here uses Angular on your day job or private projects? Okay, everyone. Cool. So, right audience, but actually the things which we are going to discuss here today are applicable to all the other front-end frameworks and libraries, because as long as it's front-end and you most likely have ESLint available, you could apply these things which we are going to learn today in those projects as well. So basically, what is it about? Probably most of us had this amazing experience when you get to work on a greenfield project, right? You have a team, you have a set of requirements, you make like a design doc, you create a repo, everybody's motivated, you are shipping features left and right. Every day you come home from work, you feel amazing, you are achieving the milestones ahead of time. Everybody is just happy, and I really wish and hope that all of you had this experience. But then, 2-3 years down the line, it might look a bit more like this, because maybe the lead developer went for a half a year of sabbatical, and then the salespeople sold the features, which of course were not planned, they're not there, and you have to deliver them yesterday. And there were bugs in productions, and we just had to make things happen and cut corners. So then it's less fun, it's kind of like feeling like you are crawling to a swamp. Then you come home, maybe you take a shower, just shake off that bad feeling. So yeah. But to put it into more engineering terms, usually it's a symptom of a shape of a dependency graph of your code base, right? So we usually start with something nice and clean and orderly, right? It has the definite left to right organization, it looks pretty cool. And then it tends to deteriorate into something a bit more chaotic, and the red color there signifies there are cycles. And the last one, I don't know if you can see it on this screen, but it's you basically see one file and an insane tangle of the dependency lines between those files. So we definitely would like to stay as long as possible in the clean part and probably completely prevent chaotic and insane deterioration of the dependency graph, or the imports between the files in our code base. And if you like those diagrams, this can be generated by the open source tool called Match, which you can install from npm, which is a pretty cool tool to help you visualize the overall health of your code base, and also to communicate this health status of your code base to maybe some non-technical stakeholders, because everybody can understand the picture, which looks crazy, and if it's full of red, then maybe you should get some more time to fix things up, right? So quickly about me, my name is Tomas Trajan. I'm a Google developer expert for Angular, and I like to say that I build, teach, write, and speak with and about Angular since more than 10 years. So we are supporting companies here in Switzerland and worldwide with AngularExperts.io. Teach workshops, Angular, ArcGIS, NGRX, NX. Get in touch if you are interested. Right, we have a free blog at Angular Experts with all the coolest, latest new things, with signals, zoneless. You can get a lot of free information there, and speak at various beautiful conferences and meetups worldwide. So why architecture matters, or more precisely, why clean architecture matters? Well, of course, it has a lot of positive benefits, but for everybody involved, right? So it's not just us as developers, which, we can, the code stays maintainable for much longer, and it's much easier to extend, but also for the company itself, right? If we can guarantee that our architecture stays clean, that it will be still easy to add new features 3 years down the line, and not just in the first half of the year of the project. So, and of course, also for the users, if our architecture is clean, with the clean separation between the eagerly loaded and lazy loaded parts, then the users will benefit with faster startup time. And also, us as developers, when we separate code into individual isolated chunks, then as we work on that code base and we save, some change in some specific file, we don't have to rebuild the whole thing, but probably only that one lazy bundle, which instead of 3 mega can have like just 50 kilobytes. So then the rebuild time goes from something like 2 seconds in unoptimized application to something like 200 milliseconds, right? So we also feel the benefits. And last but not least, the clean architecture gives us isolation guarantees, which are often overlooked. And basically that means if we have a large application with maybe 30 lazy loaded features which are very complex, if we have these isolation guarantees, then I know if I'm making change only that one lazy loaded feature out of 30, I could not have had any impact on the rest 29 of the features. And that's like a huge benefit because I don't need to read so much code, I don't need to understand so much code, I prevent like unintentional bugs, so those isolation guarantees can be very, very powerful. So now how could that look in practice in Angular projects? So like every Angular project has like the eagerly loaded part, which is there from start, right? So some kind of core infrastructure, like you load the user state, maybe you show like some initial layout, and then preferably all the actual meat or like the business features are implemented as lazy loaded features. You can call it feature, you can call it page, you can call it navigation, however you like, but it will be separated something like this, and then probably we'll have some kind of concept of shared of reusable UI components, right? So and then you would implement this and it would look something like this. You will have some kind of folder structure which can express this desired architecture which you came up with your team and you want to follow. But the problem with that is it's just like a hope-based architecture, right? We created a design doc, we created the appropriate folder structure, we described how people should implement things inside of those folders and what they should consume and what they shouldn't consume, but we are kind of just like hoping that they are going to do that, and we might try to validate it manually, but it's just not a realistic task, because without the support of automated tooling, it's impossible that everybody pays 100% attention for every single review for 4 years straight. That's just not how the world works, right? We have to be realistic. So basically what tends to happen, unfortunately, is that some imports which are never correct, so like the imports as in like dependencies between the TypeScript files, creep their way into our code base. So for example, it is never okay that the eager part imports something from the lazy part, because then that lazy things becomes eager. So we are breaking the lazy loading, right? Or like the reusable UI component should never ever use another component from a feature. The other way around is okay, but never like the reusable component can never really consume something from the feature. And preferably, we also want these features to not consume from each other. We want to keep them as isolated as possible for all these isolation guarantees, and even things like extracting the whole feature in a library to share it between multiple applications, or deleting it outright and rewriting it from scratch, right? So we would like to prevent all of those, because those are like never really correct. So hope is great, but folders will look correct, but the wrong imports do make their way into code base, usually behind the scenes. So we break like the one-way dependency graph, so that's like between the eager and the lazy, right? And this will have negative impact on the maintainability and extendability. You want to change something, and then at some point you get this experience, and it happened to me for sure many times. You pull like the one file of the code base, you want to change something, and then you feel like you are pulling the whole code base because the graph got very tangled, right? So we don't want to do that. And of course, when it's all tangled and it's all built together, so we are building bigger bundles, that's worse for the users, for the startup performance, but it's also worse for us as developers, because then every change needs to rebuild bigger amount of JavaScript, and therefore the rebuilds take longer, then we lose our attention, we find ourselves on YouTube watching cat videos, and that's just not what we want. We want to get the stuff done, right? So, and of course, there will be always a way, for example, if you wanted to make sure that like all the features are, isolated, you could manually try to click on every single folder and try to search for other features names with like relative imports, but that just doesn't scale, right? But I did that in person before I knew about this, but it just doesn't scale. So can we do better? What if we could, and without hiring like 3 other people who would just like validate the dependency graph for us, what if we could get something like this? So we're in the editor, and we are in like the authentication service, so that's something probably in a core, eagerly loaded, and we are trying to import product service most likely from the lazy product features. Wouldn't it be cool if ESLint told us, hey, you are actually trying to import from feature into a core, and we agreed with the team and with the architecture that this is never okay. So it would be really nice to get such a violation message early in our editor, and then of course also in the CLI, as you know, in your continuous integration pipeline on the merge request, and you cannot merge such an implementation into your main branch because it just doesn't fulfill the prescribed architecture without any manual contribution or any manual effort. So, and this is where the automated architecture validation with ESLint comes in, because we can achieve exactly that with a relatively little effort. And today we are going to learn how you can define your own architecture vocabulary of those building blocks like core, feature, UI, or whatever you like, and how to define rules between them. So most projects, front-end projects, already use ESLint. That's great. You don't have to add the setup. Like, it's highly likely you have this. And if you don't have it, you write ESLint, and the whole setup happens automatically with schematics. So that's very nice. So and we will get the validation in the editor live and on every merge request. So we do not need to depend on hope, and we prevent all the undesirable imports and preserve the isolation. And this can be done with the ESLint plugin boundaries. It's like a third-party plugin, but it seems to be very well maintained. They already provide support for the new ESLint 9. We changed, from the JSON config to the JavaScript config. So it's pretty cool. It's easy to get started with. And the big thing is it works with folders. So there is like no overhead in your source code. So first question, does anybody here use NX? And for the people who use NX, did you define NX plugin boundaries rules? Okay, so some of you do. But then you know that those work on the level of the libraries, right? So whenever you want to enforce some kind of like validation between those building blocks, you have to extract it as a library. And of course, in NX, that's kind of like the correct way to go about it. But NX has like a learning curve. Not everybody wants to spend time on it. And there is some overhead, because then you have these project JSON files where you have to define the tags. Then you have to make sure that those tags are up to date when you move the folders around. So it's not for free. But here, this one actually just works with your folder structure. So there is literally zero information about your architecture inside of your source code, besides just the location of the file. So it's very convenient and like very lightweight. And the whole thing works with two main systems. So first of all, we have to define like these architectural building blocks, or like the types, so like the vocabulary, like you have core, you have shared, or UI, you have feature, maybe you have pattern, whatever you want. And then we can define the rules between those types. So, and we will learn this on a very minimalistic example, so that way you can take this knowledge and define the system which makes sense for your specific application and implement it for yourself. So the type example, every application should have eager and lazy part. Even if you have a single page, that should be your first lazy loaded feature, because that way you can extend it with ease in the future, right? And it will, be implemented or encoded in some kind of folder structure. So then let's define something like a core type. So, that's like the headless implementation, which is eagerly loaded. So like some authentication state, maybe some API interceptor, all these kind of things. And then we will define a feature type, or you can call it like a page, which is the actual implementation of like some business logic, some components which allow user to perform like some kind of business flow. So this can be like components, services, all this kind of stuff. So, and then what we want to encode with the rules is that we honor the one-way dependency graph, especially like that the lazy part can depend on the eager, so the lazy features can consume from core, but not the other way around, and the isolation between the features. So then core cannot depend on feature can depend on core, feature can import like the user service to see like who is currently logged in and what they should see, and the feature cannot depend or import from another feature. Or if you prefer picture, this encodes our very simple architecture with two types and couple of rules. So it's like a good starting point. So we see eager part, core cannot import from feature, features can come from core, and the features cannot import between themselves. Great. So how can we implement this? Let's get hands-on. So first of all, we assume we already have ESLint, and if we don't have, we just do ESLint, and the setup will happen automatically with the Angular schematics. And then we manually install this plugin boundaries and ESLint import resolver TypeScript. And then we have our root ESLint config.js file. So this is already ESLint 9, but of course with like the JSON or ESLint 8 and before it would look very similar, but this is like the latest signals syntax with the new ESLint 9, which uses ESLint config.js. So and then, like, of course, this applies to the TypeScript files. This is where we want to validate our dependency graph between the TypeScript implementation. And then there is some kind of boilerplate, which will be always the same, which you also find in the documentation page of that plugin boundaries or on its GitHub README, right? So you have to enable the plugin, and then you have to provide this little setup which allows it to recognize JavaScript dynamic imports, which are used to lazy load the features or like components in Angular. So that's just like some kind of boilerplate, so it recognizes all the syntax which we are going to use in practice in our Angular code base. And then we can also provide some kind of preset. So like a good preset is strict, which ensures that every single file in our source has to belong to some kind of architecture type. So now if we say like we have only these two types, the core and the feature, of course we could not use the strictness because every Angular application is also main.ts and like app-component.ts, but more on that later. So that's some kind of boilerplate. You will find this in the doc, you put it in your file, and you can completely forget about everything. And then you can start defining the types, right? So we have to define these architectural types, that vocabulary which recognizes those building blocks. So again, in the same file, then we provide the new property settings for the TypeScript files, and we provide the configuration in boundaries/elements array. So in the first type which we wanted was called the core, and we say like that the type is called the core, and if any file, any TypeScript source file which has a file path which contains core keyword should be recognized as a core architecture type. So what do I mean? If we have a very simple Angular CLI workspace, we would have our application in the source folder. So there will be something like source app core out service or source app core user, whatever, if you use NGRX. So then with such a architectural type, it will be recognized that those two files belong to the core architecture type. And as you can see, this also introduces some kind of limitation because that core represents like a reserved keyword. So it will probably not make like, you know, features, order features/core, but we will not have that many architectural types. So this limitation is relatively meaningless. Like you can come up with the names which do not repeat themselves, and we don't have so many of those anyway. So that way those files get correctly recognized as a core architecture building block. Now let's the second type, the feature. So again, it's a type feature, and then we say whatever has a feature in its file path should be recognized as a type feature, but we add this one extra thing /star, and what this means is like whatever the next folder comes after that should be recognized as a feature name, and we want to store that in a feature variable, which you see here, capture feature. And this will be very useful to be able to prevent features importing from each other. Because else, if everything is just feature, how do we differentiate? So we have to capture its name. So how does that look like? Source app feature order service, source app feature dashboard component, and let's say dashboard item component. So now, first and foremost, because there is a feature keyword in like the file path, it gets recognized as a feature architectural type, but because we have that star, we also capture that next folder as a feature name, and this will then allow us later to validate that features cannot consume from one another. Perfect. So we have the types, and now it's time to set up the rules which govern how those types can consume each other, right? So again, previously we were in the settings, now we are in the rules, so again like a standard ESLint thing, and now we are defining the rules for boundaries element types. And okay, of course we want these validations to be error, because we don't want anyone to be able to, you know, merge this into main. And by default, we say that what is not allowed is disallowed. And then we say, okay, if the file was recognized belonging to a type core, it can only depend on other files from the core. That's kind of realistic. I mean, core, is this headless infrastructure eagerly loaded, so it should never really consume from feature, it should never really consume from UI, from nobody else. So we say, okay, core can only import from itself, from the core. And then we say, okay, feature can consume from the core, but that's not enough. Feature could consume from itself, but that's also not enough, because what we want is that feature can import from feature, but only from itself. So this is this point where that variable which we defined previously come into play. We say, okay, feature can import from core and from feature as long as the value in that variable is the same. So like, order component, order service, from the order feature, we'll have the order as the feature name. This will be the same. So this is allowed, but we will not be allowed to import from product feature. So how does that play out in practice? So again, authentication service, something which is most likely in a core authentication state for the whole application. And we would, for some reason, try to get something from the order service. It will tell us, yeah, the core tries to import from the feature, and the name of the feature was order, but this is not allowed, right? This is never a correct kind of import. Or we are in the order feature, which is order service, and we want to use product service from the product feature. We get, again, very descriptive message. File from the feature order tries to import from another feature, but the other feature is product. And again, it's not the same feature. We want to isolate them. This is never correct, so we can prevent this, and we get very descriptive message. And then if we want to solve it, we probably have to, refactor it a little bit and maybe like extract a subset of that product service functionality into core, and that way it can be consumed by both features. So whenever you want to solve this kind of violations, it usually is solved by like extracting one level up. So if you have like two lazy features and you want to reuse something, it has to go to the core if it's like a service, or it has to go to UI if it's a component. If you have a lazy feature and you have two lazy sub features, again, you want to isolate, so then you put it one level up to the parent lazy feature. Great. So now with the Angular CLI workspace, it's actually a pretty good Monorepo setup. So it happens to be, especially nowadays with the ESLint build, it's really not a problem to have single Angular CLI workspace, let's say with 5 applications and 3 libraries. It works completely fine. The build is fast enough, so it's a pretty good setup, and you do not need Enix. Like Enix, if you have, if you have 30 apps and 70 libs, of course, go with Enix. But for many projects and teams, actually the standard Angular CLI workspace is completely fine to develop 5 apps and 3 libs. So how can we extend this to support us there as well? So we had those 2 types, core and feature, but now we can extend them with like a base pattern and base capture. So those of you who use this kind of multi-project Angular CLI workspace know that all those projects are usually stored in a projects folder. And then there is like a project name, so that can be order app, product app, lib A, lib B, and then it's like source app or source lib. So and similarly to what we had with the feature, whenever there is a star, we can capture that into a variable. So that way we capture like this app or lib name. And we can do, and if we do that, then if those paths look like this, then we see, okay, it's a core, because there's a core in its path, but we also have this base path which recognizes the app name. And again, we would say like, of course, core from one app should never import from core from another app, right? If you want to share between the apps, you have to extract into a library, one level up. So if we have 2 apps, we go one level up into a library. So again, we recognize this. Same for the feature. And then we can extend the rule set to not just say like, okay, core can consume from core, but only if that core is from the same app, right? So like the user service from app A should not import the authentication service from app B. So we can prevent this. And as you can see, this works exactly the same as what we did previously with the feature, that the feature could consume from only itself, like the feature from the same name. So now so we extended the core, we also extended the feature, and then we say, okay, feature can consume from core if it's from the same app, and feature can consume from feature if it's from the same app and from the same feature. So it's not really, I mean, there is like some syntax involved, but it's really not that crazy. And as you can see, it's pretty powerful, and it allows us to express any kind of rules which would fit our own architecture vocabulary, which fits our own use case. And it's really not that much code to define to get started. Right, so now that we have this, and we have two applications in our workspace, and we have out service in one application and user service in another, and we would try to import it again, we say, okay, the type is core, but then the applications are different. So again, like that violation message is very descriptive, and it gives us pointers how to solve it. So and in this case, if we want to reuse some service between multiple applications, we would have to extract it one level up into a library. Oh, right. So how do we do this for the libraries? Because if we add the libraries, we also want to validate them, right? So it works exactly the same. And as you can see, this gives us a lot of flexibility, and there is no overhead. We only defined a couple of rules, but in the source, we didn't have to do anything besides following some very simple naming convention, which we are doing anyway in practice. We have some kind of folder structure. So how does it look with the libraries? So here we have, collapsed all the previously defined types. So now we define type library. And we say, like, if it's in projects, then there is like a library name. If it's source lib. And that's the cool thing with the Angular setup, that automatically we can recognize them because apps have source app and libs have source lib. So we don't have to do anything special. It helps us to recognize that it's a library. And because we have this new type, again, we can say, okay, so core can import from core from the same app or from the library, right? So as you can see, like, we added a couple of types, we extended it. We extended it also to multi-project setup in Angular CLI workspace. And it's usually like one line, or like, let's say 4 lines to add a type. And then it's like one-liners to allow the consumption of that new type in already existing rules. So it's very powerful, and it's very terse. We don't have to write a lot of code or configuration to get this working. Right, so what about the strictness? So we've seen already in the beginning in that boilerplate setup that we can enable boundaries config strict, and what this means is that every single file has to belong to some architecture type. That's very beneficial, because if you don't account for some files, then of course they can add those wrong imports, or we are allowed to add those wrong imports. But then again, like, if you have something like just config ts, well, do you really want to define architecture type for that, just so that you account for the strictness? So another way to go about this is to specify the files you want to ignore, right? So maybe you do not want to or need to track like how the other config files are like consumed, because they are not going to be consumed. Or for example, environment files, like that they can be used anyway everywhere. So you can actually exclude some of those files in an ignore list which also supports wildcards with the star. But in general, it's a good idea to have everything strict. That means all the actual source belongs to some architecture type, and then those which don't are explicitly ignored in that ignore list. Then another thing which we had was this default disallow. So that was here, as you can see in those rule definitions. So that's also a very reasonable default, because you want to say like if I don't provide the rule, it's not allowed. So only what was encoded in the rules is actually allowed in terms of like importing from each other. So those are two really good defaults. Of course, the trade-off is that if you have a new project, then of course you want to enable them from the start, but if you have existing project, then you cannot really enable them, because most likely the architecture is not completely clean. You have those bad imports. So you probably need to start not strict, define first 2 types, then clean it up, then add additional type. And at some point, you have types for everything, and every single source file was accounted for, and then you can enable the strictness. So that means also that if we added that strictness, and this example which we are building until now would fail because we didn't account for app component.ts, main.ts, right? So that would fail. All right, so the journey continues. I would strongly recommend to explore this and add this to your projects. We had like a really great experience with that in a large enterprise environment with more than 220 Angular spas and 30 libs. It is possible to add it gradually to existing projects, as we already discussed. You always start like you define first two types and first couple of rules between those types, and then you make sure that you have no violations, and then you can add additional type and the rules between those until you accounted for every single file in your code base. And you repeat, and then once you have it, you enable the strictness and happily ever after. So yeah, it's really possible, it's really valuable, but the point is you do not have to do it perfectly. Already having some types and some rules is much better than having nothing and like adding more and more of those undesired imports and dependencies between the parts which should never really know about each other. So and then if you are creating like your own, rule set, like, I mean, there is, some good defaults, like probably you have some lazy loaded feature or page, for sure you have some kind of layout, for sure you have some kind of core infrastructure, for sure you have some reusable UI components, but like, let's say you do your own vocabulary, so what you should be aiming for, right? Because we don't our code to look like this, so we probably need some types. It's not just like the one type, like source can depend on source, like okay, then we are back to starting point. But probably also don't want something like this. We don't want to overdo it, like, because this tool should help us to be faster in the end. So if we created like a very intricate architectural building block vocabulary with 50 building block types and hundreds of rules, and then you want to do something and you realize it takes you like 3 weeks to add a button, and that's probably also not that great, right? So we don't want the tools to become too annoying, because that way people just start to disable them, start to hate them, and that way you lose those potential benefits. So something like this could be a very good example. And how does this relate to what we discussed so far? So imagine that this thing is kind of like this thing is like a feature, right? So you have, features, feature, whatever, order feature. And then you say like, okay, as long as this cannot impact rest of the code base, if that feature is kind of dirty inside, it's not really a big deal. Because, we can still delete the whole folder. We know we are allowed to do that because it could not have impacted rest of the source. So then you can move quickly, break things, get dirty inside of the feature, but we still have these guarantees that it doesn't poison the whole code base. And I think that's like a very reasonable middle ground to aim for when you are defining your own architecture building blocks. Great. So, and that way, hopefully, or not hopefully, if you do this, then you can guarantee that you stay, or like the health of your code base and the dependency graph stays like this for a whole duration of the project lifetime, and you can for sure prevent descent into chaos or insanity, right? And if you want to save time and just get started with like a time-tested proven preset, then you might be interested in the Angular Enterprise Architecture ebook, which I wrote recently. Angular 19 standalone first example repo, which you can get started, 180 pages of content, lifetime access. People from the community seem to like it pretty much. It has this architecture in it. This is how the content looks like. People really seem to like it. And you can get extra 33 off if you do Vox Days Zurich 25. And you can find it like by Googling, it's just Angular Experts. So that's all for me for today. Thank you for your attention, and I hope you will implement this in your workspaces. Thank you. Do we have some questions, please?
Hi. Thanks a lot for the talk. It was really interesting. You talked a little bit about NX. Can you give the main differences between your setup and the similar one using NX?
Right. So with the NX, like to have a rules between some pieces of implement, like source code, it has to be a library, right? And then it's like, in ideal case, NX repos consist of like hundreds of tiny libraries. But what I've seen in the wild is that people have NX, but then they have a couple of big libraries in it. And then you lose that granularity because you cannot validate inside of the library. So it has to be like on the library level. So that's one thing. Another thing is that NX, and especially like existing repos, come with quite some overhead. Like to create a library, there is quite some files for the library, including this project JSON file where you have to specify that the tags. So it's type UI or, you know, scope, whatever. Advantage of that is you can have more than one dimension. With this approach, you can only have one dimension, so you have only type. With NX, you can have as many dimensions as you want. But then the downside is if you move that library around inside of the file tree, those tags don't get updated. So then you have to create some custom validation script to take care of that. So, but there is like actual overhead inside of the implementation to recognize those types. Here, there is nothing in the source code. You don't have to change your source code at all. The only thing is that you follow some kind of convention where you put your things in the folder structure. So that way it's extremely lightweight. And I mean, usually people already have some kind of nice convention for the folder structure to start with. So that way it's very easy to add this and just describe it, maybe move a couple of things around, but you don't actually have to change your source. And that's like a big difference. Thank you for the question. Anything else, please? Anybody else?
Another NX question. But you can mix those two things. You can.
You could, yeah.
Yeah. Okay.
Yes, yes. So, but then it's kind of like, if we do NX, we should do NX right, and really have like, you know, let's say 1-2 components per lib. But yes, it's possible to mix it. It's possible to have NX just to do like the relationship between the libraries and the apps, and then still have this kind of rule set, just plain ESLint plugin boundaries for the internal structure of those libs and apps. This is possible, 100%.
Thank you.
Perfect. Same question. Did anybody use this for their Angular CLI repo? No. Nobody. Nobody. All right. Well, I guess then that's it. If there are no more questions, thank you for coming to this late session, and please enjoy the apero until next time. Thank you.